except we started in an absent industry. What does that mean? We don't have any best practices for us to borrow to build an organization. And often building an organization doesn't have any references usually. There's a difference between, building a franchisee versus building something from scratch. But in our case, we don't have talent also because this is an absent industry. So nobody has been trained to do this or to build robotic arms and things. And especially we are starting in a geography which is not used to building this and commercializing this at least to a product, right? And we also started in an investment market which didn't understand this space yet, right? And that's largely true even today, but at least now there is a lot of interest towards deep tech.
Hi, wherever you're joining me, I hope you're doing well. Welcome to India Tech Report, a platform dedicated to chronicling and supporting the growth of India's deep tech and climate tech ecosystems, one conversation at a time. I'm Hari Arakli, and in today's episode, we dive into the future of robotics with Gokul NA, founder of CynLr's or Cybernetics Laboratory, perhaps one of India's most advanced companies in this field. CynLr is headquartered in Bengaluru with an advanced R&D Lab in Switzerland and a growing customer-facing operation in the US, where Gokul's fellow founder, Nikhil Ramaswamy, is based. The entrepreneur duo and its 85-member team are tackling a challenge that scientists and engineers have been working on for several decades: the ability for robots to intuitively handle unfamiliar objects without custom programming or prior training. In this conversation, Gokul explains their new object intelligence stack, a system designed to imitate some of the functions related to how a human brain might learn, much like a baby impulsively grasping a new toy without knowing its name or purpose. By shifting the focus from algorithms that work on data to the physics of objects, CynLr's intelligence stack is what Gokul describes as the precursor to a manipulation OS. Drawing parallels to Apple in the 1980s, Gokul shares his vision for a future of object computers and microfactories, important components of CynLr's vision for global manufacturing, where instead of gigafactories, we might have fabrication facilities as small as a car dealership or even a garage. Gokul also talks about some of the challenges of building a company like CynLr in India, where many important ingredients are missing, and what he thinks the industry can do to change that. Gokul, thank you for doing this, making time in the middle of your very busy work day.
Absolutely. Thank you for doing this with me. And I think this is the third time or fourth time that...
We've had some wonderful conversations together, and for me, it's really exciting to be doing this in the middle of all your robots.
The actual place.
Probably the first time you're doing that. Although I think in your office you've done a couple of interviews. And also I think for me, the first time I'm doing it on my own podcast, the India Tech Report, that much more personal excitement. So you are probably one of the most advanced and best known robotics companies in India today. So I won't get into a lot of the background. So I should say for our audience, one of the context sort of news pegs of this conversation is that you've very recently announced a really sophisticated object intelligence stack, as you describe it, and we'll get into what that means. So I'm going to sort of dive right in. Maybe you can take 2 minutes to just give people an overview of what CynLr is today, and we'll go from there.
Right. So CynLr is Cybernetics Laboratory, in short. And what we do is to make robots more capable in handling unfamiliar objects. Today, that's a missing piece in AI, because of which adopting robots for automation is very complicated for customers, especially in automating for manipulation tasks. You're mating parts, maybe your car assembly or a mobile phone assembly, and so on and so forth. It's a very complex task today, and also makes manufacturing very, very complicated as a business if you have to go about automating it, right? So it all lies at the crux of AI not being able to learn and adapt on the fly, where if they are unfamiliar objects and unfamiliar situations for which the AI has not been trained for, if they are not able to adapt for it. So all that missing piece of stack is what we build. So the gap that robotics has today to handle objects like human beings do is what we build essentially as technology stack, right? So all the way starting from the sensors, vision systems, the robot manipulation ability, grasping ability, and so on and so forth.
Mm. And along there, you've actually built the robots as well, right? You've couple of
Right,
good
right.
robotic arm products.
So we have three genres of approach in general, and so from an algorithm point of view, we borrow the hardware stack that is available readily, and then we have a customization where we own the design, and then we get it customized by the suppliers, and there is some where we build from scratch, right? So there are some components that are absent in the market that you don't have anything about, so we buy, and so we are essentially, we don't want to do things that has already been done. We want to do things that are missing, and given our size and capacity, we can also do only, can allocate even that, we can allocate only very specific things that we can actually build by ourselves. So we do all three. So we borrow as much as possible that is available outside, and for all the things that we could customize, we customize. All things that is absent, we build from scratch. So
Okay, so let's jump right into the latest product that you have or platform that you have launched. You've described it as an object intelligence stack or a platform. Tell us what it's about in some layperson's terms.
right, it's basically imitating the human brain. That's what object intelligence is. The portion of the brain that makes a baby very curious about objects and go and pick without any prior understanding. For a baby, the world is entirely new. They have not been trained on any of the objects that they have seen before. Like, it will go and pick a spoon, but it doesn't know that it's a spoon that is used for eating and help to eat. It'll just simply put it in the mouth and throw it out, right? So that ability to act impulsively on any object presented in front of them without having to do any prior training or custom programming is what we call as object intelligence stack, right? So that is a multi-layer stack. Starts from the sensing, which can understand what's happening in the world, and can active sensing. What we say as active sensing is, if I give you a coin, you don't keep staring the way I gave it. Take millions of images, train on it, come back and then recognize what's there in. All you do is just tilt so that you can see it very clearly. That's an intuition that you have in you, right? So that sensing ability, dynamic sensing ability, is what we add to the system. Now all the way till the software stack, right? So from hands, grasping, all of this as hardware on one layer and the intelligence on the other layer. So mirroring intelligence on the other layer.
So is there a hardware component as well to this, what you release now?
Yes.
Oh, okay. That's something I didn't know before I came into the conversation. Interesting. So is this different from the hardware that is already running your Cyro and Cynoid robots?
Cyro and Cynoid is the end outcome of it. That's the difference between the M1 processor that Apple uses versus the iPad or the Apple laptop that they actually make. First, when we say hardware components, basically the sensing mechanisms, the grasping mechanisms, which again is used as sensors in itself, right? And the force torque sensing that we build into the arms, how two arms coordinate between each other, physical control, and the components that are needed, the material that we use to build those ability into those systems. So those are all the hardware layers. And then exploiting them to bring about more intelligent ability is what the algorithm layers are, which is what we partnered with IISc to imitate, to understand how some portions of the brain work with, and then we start imitating those portions into our code. So
now, what I meant was, I wanted to understand better whether the object intelligence
has
stack
those hardware stacks.
is different from what was already running.
It is.
Okay, it's a
So the
completely
components that
separate.
go into it is part of the object intelligence
Okay.
stack. The result of it is Cyro and the robot.
So those components, like you said, will include semiconductor chips and
vision stack entirely, the grasping stack entirely, the pieces of sensing.
And these are all you have built in-house and are proprietary to you now. Okay. So I'll come back to the commercial aspects of this down the line. Can you talk a bit more about the IISc collaboration? It's a good example of how now, real deep tech ventures like you are collaborating with academic researchers and something, a very welcome and promising change in India's ecosystem.
Yeah. It also is the demand of the problem that we have in hand. So the way we have done machine learning today and the AI per se that is a result of machine learning is our assumptions of how brain work, but not how actually the brain does work. It always brings the question of, can you actually replicate the human brain? I don't think so. We can't. But some functionalities of the brain we could imitate in a code format, right? So, and those aspects that are missing is what, in fact, our knowledge of how brain functions also is very limited. And to some of these primitiveness that I actually talked about, the intuition that we talk about is very less studied. And that's the reason why we partner with the Center for Neuroscience at IISc, and they help us throw some light into how brain functions in some of these aspects. And we're discovering, as part of it, some of these researches have not been done yet. So we're also doing some new researches around this to discover how the portions of brain is acting on these facts when it comes to these kind of tasks, so that we can actually imitate those as codes and machine learning methods in our object intelligence stack.
And I want to mention to our audience that you've taken 5 years of hard R&D to build this. What's a good way to illustrate how this stack actually works? Is this like an operating system? And people are very familiar with Windows or Linux or macOS. And obviously, in terms of smartphones, we all use Android, iOS every day. Is it like that, or is it something different?
It is. So I think easiest way analogy that you can actually think about is we are like Apple in 1980s, the Lisa computer, right? So where if you want to take whatever that we discovered as a technology to the customer, they need the full system for them to, as a solution for them to kind of work with, right? So whatever that we have today, it's precursor to an OS. What will lead to is an OS for manipulation, right? So the future result of an object intelligence platform or a stack that we have will be something called as a manipulation OS, right? And possibly it will result in we creating like an app store, we will have an object store and a task store in the future. But this is the future that we are working towards. What we have today is the pieces that are needed to build that OS. And that's what we are building today. And similarly, for the customer, it's an object computer that we are giving, not just an OS, Microsoft OS. We are giving a full stack, like how if you go to an Apple, you get from OS all the way to your laptop entirely, right? So that's how we are going to the customer with.
So briefly, in the context of sort of global development of what people today call physical AI, or sort of loosely interchange it with embodied AI and all of these terms.
Right.
In that context, where does the OIS sit?
I think we precede the concept of physical AI by at least 2 to 3 years. When we started on the idea of object intelligence from the starting, from our first fundraise in itself. So we have been much earlier in interpreting, saying that, maybe another way to put it is AI is data obsessed. Robotics today is form factor obsessed. What we are obsessed about is the understanding of object. This is a problem that people have been trying to solve for more than 60 years now. And automating object manipulation has been a dream in most cases. Even today it is. A robot picking a screw, putting it into a screw hole without slipping it is a big problem. It's not just an intelligence problem or some algorithm problem somewhere. Algorithm starts from the hardware, right? An algorithm does not start from just the software layers and data that you actually look at. The difference in the approach is where we are. Conceptually, we are all working towards the same problem, solving the real world object manipulation, right? Except we are more object centric and object focused, while they are more data focused and what is already been built in large language models and how it could be translated to a physical world. And so that's where the distinction of approach is. But both of us are chasing the same problem, be it a physical AI or a skilled, or you have different approaches and methods to commercialize on one side and what you're using as a tool. But the problem that you're trying to solve is the same. We are more focused on object and the physics of the object and bringing that to the robot to intuitively understand it. And we think that's the key layer that is needed. Even for a human being, that is too intuitive for us. We use that intuition to train and teach a person to do a meaningful task. A baby's ability to go and grasp an object is not taught, is not programmed. They just go and grab it. They will pull your spectacles, they'll pull your hair, right? We correct their action, right? We say, hey, you don't grab the spoon this way. You grab it like this. You grab it like this. put it on the rice like this and then pick it and then put it in your mouth, right? So that's how we teach them, right? We do only corrective actions. But the ability to act on it, on those corrections, is inherent to the system. Without that, we believe it's going to be very hard for you to realize any form of physical intelligence or embodied AI or whatnot. And that is what we manifest as object intelligence per se. So,
So today, what are some early sort of findings in terms of what robotic arms, for example, at the simplest end of the spectrum, maybe just one robotic arm, maybe most complex side of it, maybe full-fledged, so-called full-fledged humanoids at the other end. Any early findings in terms of what is possible now with the object intelligence stack?
the stack per se is borrowable across different form factors. It's not form factor tied, but it is more about sensor stacks tied. So we are more sensor obsessed than the actuator obsessed. So actuation, as much as you have sufficient freedom to act, is a solved problem, right? Then what humanoids are solving is a commercialization issue, and the form factor, supply chain, and so on and so forth, right? And then hoping that this will universally solve a lot of issues, right? For us, we are transportable between. We are also relevant for humanoid form factor also if they want to use it from a sensory stack in enabling those hands to do those actions. Not on the mobility side, but that much, but on the action side to a large extent.
So this is this can work on any robot, or is it proprietary even in terms of?
So it is proprietary to our architecture.
Okay.
So analogically, it's equivalent to ARM. Anyone forms these kind of an architecture with all the sensors that we have, any of those systems, it is portable. But if you don't have 3-arm systems, if you don't have 4-stock sensors in all your joints, if you don't have a vision that is dynamic enough with a moving eyes and so on and so forth, it becomes harder for you to import our system. But it doesn't have to be the same components that are used.
Right.
It could be any components that you can actually put. That's equivalent to, I have an x86 architecture, whether it's an AMD processor or an Intel processor, my Microsoft OS can work on it, right? Or I can build the same laptop with the motherboard and so on, and you can replace the processors quickly. That's how you could imagine this. Our IP is translatable between all of these systems as long as the framework is maintained, the x86 framework is maintained.
So on the commercial side of things, how will this work now?
So this is a journey for us, given our phase and stage where we are. What we are doing now is not how we would be doing. Eventually, it's going to be largely the object store and the task store will be the bigger revenue model that you want to get into. All right. Currently, it will be taking solutions to the customer because we are a technology company, technology first company, building technology from scratch. But for the customer, it has to be translated into a solution. There is no translation engine in between, industry engine in between. An established system, you may have a system integrator in between, and you may have suppliers, distributors, and so on and so forth. All that is absent largely in a robotics industry or in a AI savvy robotics industry today. So because of which we have to package and then take it in terms of solution to a customer. So today revenues initially will be solution based. Then after that will be replication, where customers will be buying the robot systems and we train the customers to program that by themselves. And we make the software interfaces and everything to be easy, so the customer by themselves can just teach the robot to do those tasks. That will be the next phase that we'll get into. So once that happens, every taught task can be uploaded to a store, and any other customer, like one customer taught how to pick a bolt and then screw it. If the customer is willing to monetize that, he can, upon his option, he can actually upload to a task store, and another customer somewhere can just simply borrow and then pay per use basis for those tasks on the same robot. So what we have essentially that way we have built is a computer form factor, where by changing the code, you can make them perform one task to another task. So by downloading a mobile phone software, or mobile phone manufacturing software, suddenly you converted a two-wheeler manufacturing robot into a mobile phone manufacturing robot, right? So you can make the transition. So that's where our bigger revenue stream that we are looking at in a big picture.
So currently, when you say solution, you mean that you have identified some tough problems for your customers and you've solved some of those with the intelligence stack, and now you're taking them to. I think you mentioned, although you've not named them, but you mentioned some sectors, early customers in your press release. Can you walk us through what they are, and if it's possible to name any customers, that'd be great.
Yeah, I can name one customer, which is Audi, and you're seeing those doors here. So one of the it's a longer journey with the customer because they're also looking at industry and manufacturing transformation. They're not just looking for automating in one cell or one task per se. Their thesis is they want a modular, reconfigurable, software reconfigurable line, not a physically. They want to eliminate hardware changes whenever they want to change from one component or one task to another. They don't want to change their physical setup. They just want it to be a software change. So they want a common form factor or robot which responds to a software change and can perform wide varieties of tasks. Now, the first test that we are doing is a portion of the door being assembled. Now, the hardest part is the mirror with its wires and then passing it through tough holes and then fitting into the door. So that's a end-to-end task that we are trying to automate, and that'll be close to a 2-year-long journey with a customer where we do phases of this. And first it'll be mirror, then that'll go next month into the pilot line. Then we will have a few more tasks. There are like 100 plus tasks, fitting the handle, fitting the inside mirror handle, glass pieces and all that. That will be another 2-year journey for us to do piece by piece of this. So once we do this, it becomes a proof of concept for the larger general assembly line for the whole car and so on. So this is one such task. We are also engaging with one of the world's largest semiconductor equipment manufacturer for maintenance of the semiconductor fab labs. We have just kickstarted that project. We are ready to see where it's a paying customer for us at this point, both in terms of purchasing a system and also revenue stream in terms of converting into a solution and a project for them. So very similar problem. The same robot is supposed to handle a variety of tasks in the bath, etching bath, and other similar wafer handling tasks. So there's an equipment to do all of these. And equipment needs to be regularly maintained, and that's a very cumbersome problem. And semiconductor fab labs wants to eliminate the dependence on humans and human error. The biggest problem for them is human error that leads to a lot of wafer wastages, which they want to avoid. And there are 100 plus activity that goes in maintaining these machines. So this is one of the other activity that we are doing, and a few more that we are onboarding now. If all thing goes well, that could be a medical equipment manufacturer that we might be able to onboard into them. So it's a variety of different industries. Also because by nature, task is very similar. You have bolts everywhere. You are fitting parts everywhere. That doesn't change between any of these industries. So these are all object manipulation problems in general. That's where we are scaling to.
And just to give people a sense of how early many of these things are is, I mean, correct me if I'm wrong, I think in the auto sector where you're working with Audi, probably only about 10% or less of tasks are automated in any way, right?
Contrary to the popular perception, where people think that everything is automated, it's another thing that I struggle the most with. People the people from outside this industry, right? For them, the window into the industry is the YouTube videos that you actually see, and properly they're always shown with robotic arms doing something or the other, right? Except body in white, which is welding, painting, and some of the buffing activity, which is possibly like 3 different tasks compared to 10,000 other tasks that a person does on 22,000 parts that go into a car. None of that is automated to a good extent, right? So your robot penetration is very, very small. It's also reflected by the way traditional industrial robotic arm manufacturing industry is. Only $16 billion 2019 number, and it has been deteriorating since then. Reason why ABB also was recently sold to SoftBank, because since 2019 their revenue didn't grow. It has always been stagnant. And largest chunk of that, 63% of the revenue comes from welding. And after that followed by painting, and a very small chunk comes from palletizing. So moving, this is including warehouses, automotive, white goods manufacturing, and so on and so forth, right? So this is how the whole robotics industry itself is split. So we are barely scratched. So the simple question that I want to ask is, GM employs close to around 150,000 people or so. What are they doing in the factory, right? So those are the tasks completely untouched. And largely it's all putting parts together. Like I said, picking a bolt and then putting it into a screw hole without slipping a thread is an unsolved problem, largely in the industry.
So in this context, I have sort of 2 threads going about in my mind right now. One is the overall sort of material orchestration, as you all call it in factories, and assembly line orchestration, where does the object intelligence stack fit in there? And then maybe the second part, you have a strong thesis on how software defined
Factories.
universal factories, maybe they hold the key to unlocking the future of manufacturing. You want to talk about these two things, the significance of this intelligence stack.
The validity or the relevance of what we built as an object intelligence stack to the customer is largely, like I said before, it's the ability to repurpose the same infrastructure for a variety of different tasks. From an economics to the customer point of view, today a customer would have to invest anywhere close to 300 million to $1 billion to set up a manufacture. An automotive customer, let's say, has to put that much money into invest that much money into making a automotive assembly line. Let's say it'll take 5 years for him to recover it on a ballpark, right? So could be depends on the volumes and whatnot. If I have to do that, maybe I have to produce 30,000 units per month, right? But the customer taste does not sustain for 5 years, especially in today's social media world. It's evolving much faster and rapidly than how. So somebody who has not yet invested into it gets the advantage of starting fresh with a new customer taste, right? Or the consumer taste, right? 2 years down the line, you risk losing consumer to the new design of the product or new components of the product. So is the technology evolution being very, very rapid now, right? Especially with EVs coming in, the kind of items that are getting added to your car is too rapid. My manufacturing becomes the biggest bottleneck for me to be nimble with my design changes. Design is always a slave of manufacturing, by which I'm losing market. It's not anymore a cost center to you. This is a market expansion center for you. Manufacturing factory is the new product, right? It's not anymore the produce of the factory that becomes your product, right? So this is the thesis with which customer is trying to reimagine their factory and reimagine their factory infrastructure in the way it is very modular and then modularizable, right? And also this will lead to a possibility of customized factories, right? Customized products, right? Products often is not customized. Your seat of your car will not be customized to your height and then size and whatnot. What if you could get that, right? What if you can back to back have a lot, what used to be premium car, luxury segment, high end segment, services that you get for your car? What if it could come to the bottom segments? What is the barrier in those cases? A system that can do variable tasks back to back from one unit to another unit, right? Because it is so hard today is why that's not feasible. But when you have a software definable system, it becomes easy for you to, make it physically feasible, right? So that also leads to ever evolving updates. The way your SaaS software is happening today, that the updates are continuously in feedback to the consumers and users. So could a car can evolve. The famous statement long ago that Bill Gates actually said, if automotive industry was moving at the rate of Moore's law, a car would be cheaper to buy than to refuel it, right? And it'll be lighter than so and so. I don't entirely recall the entire statement, right? That transformation could, if not for the size and the refueling aspect may happen, but for customization, it will actually happen. The SaaS idea would actually happen, right? If we exaggerate this to science fiction imagination, most probably the factories of the future will not be gigafactories, it will be micro factories. And they'll be universally capable of doing and scaling to wide varieties of nations, products, right? And possibly your service centers here will become the customized manufacturing centers for you. That you can go and get your car fabricated there to your taste and to your needs, with the platforms of the technology maintained within as it is. And possibly even your other gadgets that you could actually manufacture out of the same. This car is today more electronics than it is, it's basically iPhone on wheels, right? So that's what it's actually becoming. So mobile phone on wheels. So all this might get integrated into one place where you could custom design your gadgets as per your use and need, right? So that's the bigger picture that we're imagining, which also will lead to, apart from, customizable consumable goods, it'll also lead to ideas of recycling, consumer mining, right? Today, if my phone is out of life, if I want to buy a new phone, the new phone's raw material didn't come from my old phone. It came from Earth. What if it comes from my old phone in itself? Because it is expensive to separate the material out, because effort is expensive. If I'm automating effort in itself, I'm automating value of material in itself. Material will start taking more value than the effort in itself when a machine like this comes about. And that's true for, in general, if you have a general purpose robotic system also. So,
Okay. As we begin to wrap up, I want to bring it back to the intelligence stack itself. Over the 5 years, can you think back to what were some of the earliest ideas you all brainstormed in terms of how you envisioned this intelligence stack eventually when we release this version?
how
Yeah,
is it actually going now?
Yeah, so yeah, I'm sure it has changed as you developed it. And as you talk about it, also give us a sense of what are some really difficult challenges you faced in developing it.
I think Nikhil and I go long ago in the for us, and at least for me, it has been consistently this has a vision. The details have emerged more because that's the difference between a vision and a execution per se. Like vision is the science fiction that I mentioned about, but how you would get to that.
Yeah.
So the details is where the devil is always in the details, and the details is where the company emerged in between. So that's the whole stage and journey of how we built it. So for us, the outcome is something that we imagined this way, and we are trying to steer it. The advantage that we have, since nobody has done this, we are doing it fresh. It's easy for us to stay the course, stay towards the vision. And it's not changing as per the users' whims and fancy, because for them also it's first time they are actually evolving to use this. In fact, it has become with the AI clout now and then the interest now, customers are more receptive to this concept that we are actually doing now. So it is making us get more closer to our vision than get digressed by it, right? But in between, we took several different avatars to get closer to this, right? We started from National Instruments when we both were together, and then we moved out, and then we started doing our services business to understand whether we could do it by ourselves. In a large setup, it's a very different thing. At least we had that clarity. Once you've witnessed it, you know how many people, what all they are doing, and you don't have all of those. And there is legacy and their own reputation, and that drives the market to even take experimental bets on you. Without all that, what can actually happen? Which if we don't have any of it and people are still interested in what you're doing, which means there is genuine need and demand that is so huge that is untapped, right? That was evident in the first 3 years of whatever that we did as consultancy with all failed projects that industry was struggling to solve. And with that success that we did, 30 different systems, we started in 2019 to build this into a product. Except we started in an absent industry. What does that mean? We don't have any best practices for us to borrow to build an organization. And often building an organization doesn't have any references usually. There's a difference between building a franchisee versus building something from scratch. But in our case, we don't have talent also, because this is an absent industry. So nobody has been trained to do this or to build robotic arms and things. And especially we are starting in a geography which is not used to building this and commercializing this, at least to a product, right? And we also started in an investment market which didn't understand this space yet, right? And that's largely true even today, but at least now there is a lot of interest towards deep tech. Back in the time, it was more of SaaS. I mean, we started in 2019 hoping that, or 2018, hoping that the consumer tech's thing was going down. And we thought now they will look at deep tech because you have to focus on infrastructure. As exploitation of infrastructure, now you have to look at infrastructure to invest more. But then SaaS picked up. And then again and then COVID came. Then that went into like a couple of years. We were arguing the internet will not be the future, but actually COVID will test the limits of the future. You will think about supply chain as the bigger problem later. And that actually happened. Mm-hmm. And now that the churn has actually happened now. And the other problem is I have the problem of building a car with cycle wheels, right? Because the components that are available are not meant for building what we are building. Neither can I vertically integrate all of those parts because I don't have the money power, neither the people power to do that, right? And the know-how to do that, right? So largely we could do only our designs, and we have been negotiating. A lot of our changes is basically negotiating to what is available on the market and what we could do, be it the choice of the arms that we use or the grippers that we build or the vision systems that we build. Ideally, we would want to change the processor in itself. best suited for our neural algorithms. I can't do that, right? I can't do die level and fab level today, but that's where we want to go. I mean, that's what would be needed. If the market responds to it and sees a larger opportunity behind it, then it's easier. Like we have Ericsson talking to us, we have ARM talking to us, trying to understand what will be the process that will be best suited for robotics per se in the future, and so on and so forth. So we're trying on those are bigger hurdles for us to get. Even though we may know what we want to do, it's not going to be easy for us to get it done because neither do we have people who know how to do it, nor do we have industries which supply components that are needed for me to do that. Right. So these are very big hurdles, and plus the fuel that is needed for me to go this mile, which is the money in itself, right? Which is structured to understand this value. So investment market in itself struggles to raise on these theses, right? So that's another absent space. Also, government is now doing a lot more to foster deep tech. I think now actually we are in the positive cycle than in the barrier cycle. So what would be more useful? What the next steps that the government on and above what they have done now is we are operating in an absent PhD and master space. The biggest issue that I have is like my whole layer is getting decimated every 2 to 3 years down the line because they have to go to masters. Right? The age is somewhere for them. If they don't do that, then PhD 30 years you will cross, marriage and everything becomes an issue, right? So and it's practical that they have to do that. I can't retain them, right? Neither can I hire PhDs and masters here, right? So this is a brain drain issue. Brain drain. Some cases might be good for the economy of India. That's in the past, all right. For the future of what we want to build, we want to do the reverse brain drain in. That needs research clusters in India where there is confidence of people who are pursuing that noble pursuit will have careers here and jobs here. That somehow we have to figure out. And it's not just a government play, it needs to be industry's response. There's a lot more blame that goes on the government, but I think there is a lot more that is not happening from the industry side. They have been waiting too much for the government to do. Government can do, announce policies, can motivate you, but the implementation happens only through the industry bodies, right? So, like the amount that we have done in terms of what we are doing with IISc for my size, right? Most investors would say, why are you biting those bullets, right? But we have to do. Somebody has to start doing that, right? We need research clusters. And when we also need, this is going to be a long-term play. We need to focus a lot more on exporting IP, not commodity. More than competing with China, we need to compete with global R&D centers, including Europe, Israel. And we need to create that India is multiple different countries in the same place. While we also have to focus on manufacturing, we also have to focus on the R&D side, not just only on the so we need to start exporting. We need to start putting measures on how much, not the number of patents that we file. We need to start looking at how much IPs are we exporting, right? So that matters a lot. Not the GCCs that we put here. Homegrown IPs that are actually getting exported, right? That goal has to be set, right? And that also needs improvement in education system, creating global standard masters and PhD programs, which means we need to open our doors to bringing really great institutions to come in here and then set up. And also the professors from there to come in and then set up here. And the industry bodies associated with them. We need to create more of research services coming out of India, not just IT services kind of a scenario. Only this could collectively fix the problem of talent being retained here. And without that deep tech, the backbone of deep tech is that mindset, right? That thinking process. Neither do they have training to think on those lines, nor do they have infrastructure to foster those thinking, right? That needs to be built.
Okay, very nice. More power to all of you if you are able to build this. And I know that this is a decadal effort, if not longer.
Correct.
From the point of view of the intelligence stack, you said it's a precursor to the operating system. So what next? Would you call this version 0 or version 1.0? And where do you go from here?
So this is basically where the BIOS layer now. So then we need further layers on and above that. We need bootloaders, and we need device driver segments, then the OS comes. So very similar to that. Right now we have put the foundation. As the utility and applications come more, so what we are trying to build is something called as primitives. So how to do a screwing action, how to do a press fitting action, right? How to kind of sense if there is a reflection, how to kind of sense without reflection. So they're all like basic blocks that we will build. And the next stage is we'll expose customers to this, and they can just make they can imagine a task as combination permutation of this. Then we derive patterns on above this, which is what we call as models. Then we start making self calibration and learning for the system, which will be the OS layer that we're talking about. So that will be probably another 5 to 7 year journey for us to get to that.
Okay, CynLr as a whole, any other updates? I mean, money for a startup, deep tech venture is always something that you do keep raising. So any funding plans and so on?
Yeah. So we do need to start investing into the supply chain. We need to have more control over the algorithm and design. One of the big problems that we have is the density of value that you're taking to the customer in the form factor that you're taking. And that is limited today by the bottlenecked by the components, and we're not able to realize the IP that we actually thought about, right? So that needs significant amount of investments that we are going to the market with a 40 to 45 million raise at this point. And I'll be focused towards doing this. Second factor is sales cycle today is too long. We want to shrink the sales cycle because there are too many validation points that the customer is seeking. Because the evidence of solution is a long journey, and that needs a lot of investment back into improving our software inside, and then building more prior modules, pre-built, application modules, and so on and so forth. Right. So that is the portion where we have to double our team or triple our team mostly. We are now 85. Yeah, it's almost triple. We need to go up to like 250 member team for us to sufficiently deliver all of these over the next 2 year period. And the engagement that we are taking with all these customers each of them are like with a potential more than 2,000 to 3,000 replications within each of these customers, right? And that we are aiming at 2028. So which means with all this potential, by 2028, if we get this investment right and then we are able to invest into it, we'll be able to produce 1 robot per day. And that's 300 robots per annum, right? And that's the goal which would help us to hit somewhere close to $40 million of revenue, and sufficiently enough for us to even break even. That's the proven model of a operation for us, and then we can expand and scale post it. Then we will again go back to scale at that time. Right, so
that means in your mind, I mean, and briefly, and this is a whole other conversation in itself, but the future CynLr, 5 years, 10 years from now, you are actually looking at CynLr as a company that will make the robots also. Not, since you mentioned ARM earlier, not necessarily a company that will evolve into an architecture builder, but you're going to make the robots as well.
True. So Cyro as a form factor as a robot, even now we are making it, and then this will continue to be so. In fact, Cyro will become Cynoid, and there are more versions of Cynoid that's going to come with complete mobility enabled. The form factors are wait to be seen, which one will suffice the most. What we are doing is, so it's the same earth that every animal being actually walks, and each one have different form factors. We are trying to borrow biologically whatever the advantages that they have. We are trying to borrow that, and so we'll also be producing some of the components in-house too. So right now, whatever they're borrowing from external market, or we will convert a lot of those into a manufacturing service company. So there is a stage. It's a staged approach. We still may not have capacity to be a vertically integrated company, because our volumes have to be higher than their net volume to be profitable as a vertically integrated company. Right. So if my volume is higher than my component supplier's net volume that he actually supplies in the market, or at least significantly larger or big portion of his total supply, then it makes sense for me to be a vertical integrated. Till then, we will get it custom designed from those vendors. But production of the hardware will happen.
And I meant to ask you earlier, when I asked you what next, in your press release, you've also mentioned an open source platform, which you've called Mantroid currently.
Right. It's not an open source platform. It is a highly modular platform where customers can pick and choose how they want to kind of integrate. So instead of being in a form factor war too early, it's too early to decide whether a 15-inch laptop or a 16-inch laptop will be successful. Right. So we are in 1980s of compute, 70s and 80s of compute. Right. We don't even know what type of mouse will be used and what type of input mechanisms we'll use for programming robots in the future. Is it teleoperation? Is it just fully animations? Or will it just be voice instructed activity, or the combination of all three, right? I think it's going to be a combination of all three. That's what is going to happen. So today it's an emerging market. Every day, new technologies are coming, new grippers are coming, new sensors are coming, and so on and so forth. It's easier to give a customer a platform, a sandbox in which he can, concoct whatever that he wants. And there are too many varieties of applications also for you to know which is one form factor that is going to rule all of them, right? We think an architecture will rule all of them, not a form factor per se, right? So an x86 architecture will rule compute, and an ARM will rule compute. But what processor size and what kind of laptops and what modules of laptops, whether it's a mobile phone format or whether it's going to be a PC format, server format, or a computer format, that will be determined based on the different applications, right? So that's where we are actually going to, and that's what this platform is going to enable. This Mantroid sandbox platform is going to enable.
Okay. Gokul, thank you so much for doing this in the middle of your busy work day. Very insightful as always. Thoroughly enjoyed the conversation. Maybe next time we'll come back and talk about humanoids.
Absolutely. Hopefully so. Yeah.
Thank you for doing this.
Thank you for doing this.
That's it for this conversation. You can find links to Gokul's bio and CynLr's website in the description. I'll be back with another conversation soon. And until then, I'm Hari Arakli. Thank you for joining me.